Good afternoon, good evening, or good morning from wherever you're joining us from today. My name is Sarah and I am the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to a Microsoft Reactor live stream event. Today I would like to welcome back to the Reactor Ron Sumida. So he is bringing to you the new Microsoft Reactor series, Build Skills, that will help you learn valuable tech skills and discover your new career path. So for whoever's joining us, whilst I'm going through our code of conduct slides today, whoever's joining us for the first time today, I'll give you a bit of background on Ron. Ron has started with his PhD in computer science at UCLA, where he conducted research on applying neural networks to problems with artificial intelligence. Today, Ron works for Atmos and delivers cutting-edge technology training at companies, universities, and research institutions worldwide. Today, we will be discussing and taking your first steps with C#. Ron will be speaking for about an hour and 15 minutes, and we will have about 10 to 15 minutes at the end for questions. However, do ask us all questions throughout in the comments section, and between Ron and myself, we'll try and answer and moderate as many as possible. At the end, we'll also share with you a link to our feedback survey with the event code. If you have time to fill that out, that would be great, because that helps us to curate our future topics moving forward. We will also share with you the link to the YouTube channel. So this session is being recorded and will be available on demand straight after today on our Microsoft Reactor YouTube channel. But for now, I will hand the floor over to Ron to begin. So thank you so much, Ron, and over to you.
Okay, thank you, Sarah. Appreciate that. Let's get started. I will share my screen. And there we go. You should be able to see my content on my screen, which is this slide deck that I'll be using to do the presentation. So this is the Reactor for taking your first steps with C#. Just to give you a little bit more information about my background and when it comes to Microsoft technologies, I've been working with Microsoft technologies now for more than 25 years. I started all the way back in 16-bit Windows, doing user interface programming on Windows 3.1. Then did Win32, did COM, started with .NET basically from the beginning when .NET was first introduced in 2002. So that gives you an idea of how far back I go when it comes to .NET and as well as the whole overall stack of Microsoft technologies. Lately, I've been doing a lot of other things too. As Microsoft has embraced open source, so have I. So I'm working a lot with Docker and Kubernetes lately. I've been doing a ton of Azure, particularly Azure AD B2C especially, and have done a lot in the last 8 or so years with Angular and React, along with TypeScript and JavaScript. So that's a bit about my background in addition to what Sarah just told you in the intro. So here's what I'm planning to cover. I'm planning to talk about, first, to give you a little bit more context around C#, I want to tell you how C# fits in with .NET. Because presumably, if you are attending this session or watching the video for it, you are new to C#, because this is intended to very much be an introductory session. So I want to give you a little bit more of the landscape so that you can fit where C# is into the bigger technology picture. Then we'll look at writing your first C# code, which would involve using normally a development environment. And the two major development environments that you would look at using are Visual Studio Code or full-blown Visual Studio, and I'll talk about the differences between the two. And then we'll get into the C# details themselves. So after we get through Hello World, we'll look at storing and retrieving data using both literal values and variable values. And then we'll also look at basic string formatting. So how to specify escape characters, verbatim strings, string concatenation, and something called string interpolation, which is normally when I want to write out a more complex string, how I typically do it. So first, let's get into this, which is some of the details of like what .NET is and what C# is. So this definition of what .NET is has really changed, particularly over the last few years. I would say the last 10 years or so, when you started to see the emergence of mobile and tablets. Before then, the definition of .NET, like when I first started teaching it, would have given you an entirely different definition from what I would give you today. But Microsoft's official definition for .NET is basically what I have on this slide, which is it's a general purpose platform for developing a variety of applications. So you've had desktop, you've had web for ages and ages, but The technologies that are relatively newer in terms of more widespread adoption is cloud-based technologies. Mobile, that's, like I say, the one where it's kind of hard to believe now because everybody's got a mobile phone with them pretty much all the time. But if you look at smartphones, they were just barely getting going in that sort of 2009 timeframe, while mobile phones themselves were around well before that. Smartphones certainly and tablets really didn't emerge until a little more than 10 years ago. Gaming, IoT, Internet of Things. Just about every device you buy these days that is electronic is connectable to the internet. And IoT, Internet of Things, very big technology because you want to be able to have those devices stream data potentially in real time to servers. And of course, as mentioned, this is what I got my PhD in, which is AI. And at the time I got out of school, unfortunately, there were no jobs. This is actually what drove me into doing Microsoft technologies, because at that time, and it's hard to believe because AI is one of the hottest fields, there were literally no jobs for people who are graduating with PhDs. And now I'm back to doing AI again in a big way because, number one, it's become so popular. And number two, it is a big part of what Microsoft's direction is with their applications. In fact, they are saying one of their stated goals is to infuse every application with AI. So that's a big part of the reason why I've gone back to it. And just as a quick side note, a big thing that surprised me when I got back into doing AI again is how little it had changed from when I was in grad school. And I'll tell you what did change and has revived the field is the hardware just got a whole lot better. The algorithms really didn't change all that much. It was more so the case that once the hardware got good enough to support the algorithms that have been out there for 30 plus years, then AI was able to show real results in a practical sense. Now, there are two major current .NET implementations, and this is something big that you need to be aware of. There is .NET Framework, and there is the latest current version is .NET 6. Both of them are very widely being used out there in industry, a little bit less so for .NET 6 because it's relatively new. But if you are starting out with .NET and C# today, brand new from scratch, I would advise you to go right to .NET 6 because .NET Framework is essentially becoming legacy. And let's talk a little bit about what .NET Framework is. It's a software development platform for building Windows applications. And I emphasize the word Windows there because when .NET Framework first came out, it really was only usable on Windows. There is an implementation of .NET Framework for Linux that's called the Mono.NET implementation, but the original implementation of .NET Framework only ran on Windows. And really, if you look at the landscape of the technologies at the time, .NET Framework was essentially Microsoft's answer to Java. In the era where .NET Framework came out, it was right at the end of the technology called COM, or Component Object Model, that I worked with for about 5 years or so, which was extremely hot in the Microsoft world at the time. Then Sun came out with Java. Microsoft's answer to Java was basically .NET Framework. And it's a general purpose platform for just developing mainly web and desktop applications originally, because that was what people cared about in the era when it was introduced in 2002. And there are three major components to .NET Framework: a runtime, and I put a link to the actual web page that you can go to if you want to read the spec for the runtime. Not that you particularly have to do that anymore, but just so you know that there is a runtime that underlies all of this. The class libraries, and the various tools that you would use for developing a .NET application, for example, Visual Studio or Visual Studio Code that I was alluding to earlier. .NET 6 is the latest version of .NET, and this was formerly called .NET Core. All right, so basically what Microsoft did was they developed this new implementation of .NET that was called originally .NET Core, and its big selling point, it's a cross-platform implementation of .NET. That's why on the last slide, I emphasized the fact that .NET Framework was Windows only originally. And aside from that mono.NET implementation, that's really the major concern, was to run only on Windows. But given that the world has evolved to much more cross-platform, Microsoft needed to evolve with that, and they developed this cross-platform implementation of .NET that they called .NET Core. And what was happening when .NET Core first came out, and for the first several years thereafter, is they were having two parallel tracks of .NET Framework and .NET Core. Well, they ultimately got merged. in the implementation of .NET called .NET 5. So .NET 5 is the one version of .NET that they wanted to have going forward. And then every year they're introducing a new version of .NET. They're flipping the major version number. So in November of last year, they introduced .NET 6. But .NET 5 was introduced November of the year before, so it would be November of 2020. And that was the point at which they said, we are going to now go forward with only one version of .NET. In other words, we're not going to introduce any more new versions of .NET Framework. It's going to be one unified .NET, and that was originally .NET 5. And then they came out with November, 1 year later from when .NET 5 came out, they came out with .NET 6. And .NET 6 is cross-platform in the sense that it is supporting not only Windows, but Linux and the Mac OS. And it's developed by Microsoft, but contributed to by the .NET Development Foundation. So that is the big picture of what .NET 6 is. And like I said, if you're starting out with C# today, I would advise skipping .NET Framework, going right to .NET 6, and that's what I'm going to be talking about in this talk. Although, frankly, for what we're going to do in this session, it really doesn't matter. Since this is the very fundamentals, very basics of C#, it works the same way. At least what we're going to cover in this talk will work the same way whether you're on either one. Right? So what is C#? Since we're going to spend this session looking at C#, talking about it, writing code for it, it's very important to know, well, how does that fit in with what I just described with .NET? Well, C# is the most powerful programming language for .NET. It's modern, it's object-oriented, it's a type-safe language, and I will talk a little bit about what I mean by type-safe if you're not too familiar with that. That will come up a little later on in this session. And it enables writing .NET applications that are secure and robust. And if you had to pick a language to use for programming .NET today, C# is definitely what I would encourage you to use. Although be aware, there are many other .NET languages that are out there, but this is the flagship language. Here are the steps of going through what we're going to talk about in this workshop. So the slides that I'm showing you right now are available via this Dropbox site. And for those of you who are attending this session live, I put into the chat a link to that Dropbox site. So you can go there and pull down a copy of the slides that I'm showing you here, which is good to have given the fact that I put in links to the various steps that we're going to be going through, the pieces that we're going to be going through. All right.
Ron, just before you kick off, can we get, oh, you've just stopped the sharing button there. That's great. Yeah, it was just the button at the bottom. That was,
yeah.
Showing.
Yep.
Oh, good.
Okay.
Thank
I didn't
you.
know whether that showed up, but that is a little bit annoying. So thank you for pointing that out to get rid of that.
No worries. Thank you.
Okay. So here is the first bit that we're going to do, which is to write your first C# code. I'll just go right to that website right now and show you what that looks like. So these are the steps I'm going to take you through. I'll walk you through this basically, since you guys don't have the opportunity to interact with me, in a two-way fashion. I'll at least bring up the website. I'll walk you through the steps of this and show you basically what you need to do. Although I would encourage you on your own time after the session is over to go back through everything and review everything. And also there are some quiz questions along the way to go through those as well to make sure that you grasp what we've talked about here. But this is what we're going to look at first, which is writing your first C# code. And the objectives here are to write like a hello world, to use a couple of different techniques to print a message to the text console, diagnose errors when you type incorrectly. And then also I want to talk a little bit about some of the C# syntax elements. So I'll click on the start button there, and that'll take me to the next piece. Now, one thing I do want to show you here is this is the general introduction to what C# is about, which I just pretty much gave you a moment ago. But I want to skip ahead to the next exercise, which is the Hello World exercise. I'll click on Continue and show you that you don't even need a development environment at all to walk through the steps of what is necessary to complete the exercises for this workshop. It's all right here on the web page. You can use this .NET editor on the right-hand side as it instructs you. And you can take the instructions and the code, read through the instructions, take the code, and just put it out to the .NET editor and run it by clicking the Run button. However, that's not what you're really going to do in the real world. So what I'm going to do, given that you can always go off, of course, and walk through these web pages on your own, and just like, for example, click on the run button, or I'll just do one. I'll do the hello world. I'll click on copy, paste it into the .NET editor here, and click on run just to show you what happens when you do. And you see that it does display hello world out there. But when you're doing real world development, or if you're going to get a lot into working with C#, you're going to need to work with a development environment in reality. Of course, you're not going to be able to realistically code using a web page editor like this. So I want to talk a bit about the development environments that are available, and I want to show you how to configure them. And then I'll be doing the steps. Like I said, I'm going to walk you through the instruction pages that you have there, but I'm going to do it inside of the actual development environment so I can show you two things at once. Not just what the labs are telling you to do, but also to show you how to do all of those things from within a real world development environment. And there are two main environments that people generally use for coding with C#. One of them is Visual Studio Code. And the benefit of code, it's very lightweight. You can install code in about 5 minutes or so, maybe even a little bit less, depending on the speed of your internet connection. And here's one of the biggest selling points. It is cross-platform. So you could be on Windows, you could be on Linux, you could be on the Mac OS, any one of those. You can use Visual Studio Code. It will work exactly the same way, independent of which one of those three you are on. If you didn't already know this about Visual Studio Code, it's actually a JavaScript application, and that's why it can run on any one of those platforms. And Visual Studio Code is all open source. Visual Studio Code, when it first came out, and I've been working with it for years now, but when it first came out, it was cumbersome in many cases to apply it to a technology because you had to configure it. In fact, I used to tell people this a few years ago. You can get Visual Studio Code to be a great development environment for just about any technology you want to work with if you're willing to sit there and configure it. However, I don't say that anymore because there's a library of extensions, as I'm going to be showing you. And they are so good now. There's so many extensions for almost anything you want to use code for that all you have to do, find the right extension, install it, and code becomes a development environment for that technology. So to give you an idea of what I use code for, it's not, the one thing I don't use it for, ironically enough, is C# because I mainly use Visual Studio for that. But I would certainly be happy using code for C#. But everything that's basically not C#, I use code. So I use it for AI development. I use it for working with Docker and Kubernetes. I use it for my Azure AD B2C work. Almost anything that I do, and I told you there's a ton of things I do, React, Angular, any one of those, I basically reach for code as my development environment. So this is part of why I want to show you how you can get going with C# using Visual Studio Code as an option. The other option, which is the way I would normally do it for a C# program of any sort, is to use full-blown Visual Studio. This is a comprehensive integrated development environment, or IDE, for .NET and C#. And the key word there is comprehensive, as opposed to the key word for Visual Studio Code, which would be lightweight. And what Visual Studio features is a whole suite of tools that make it a whole lot easier for you to do development. And it goes above and beyond what's there in Visual Studio Code. However, code has, I would say, around 80% of the things that you really want to do day to day. So either one of these is a very reasonable choice for getting started with a development environment. So I want to talk a bit about what you need to do to work with either one of these two environments. And I'll start with Visual Studio Code. So assuming that where you're going to start from is with .NET 6, this is why I went through the two major implementations of .NET that are very valid options for working with C#. I advise going with .NET 6 because that is, like I say, the latest and greatest. And why not, if you are getting started right now, work with the very latest version. Now, if you're going to do this with Visual Studio Code, you have to download the .NET SDK. So I'm going to take you to the website where you can download it and download the latest version. So it's this website right here. I put it into the slides. And what you're going to need is to get the SDK. If you'll notice, you can get it either through the installers or the binaries, depending upon also the operating system and the CPU architecture. So let's assume for a moment that you're on Windows x64, which I'm guessing was going to be the most common scenario. Although I do see a lot of people with Macs these days as well. So if you're on Mac OS, then you'll want to choose depending on your processor, x64 or ARM64. And if you happen to be on Linux, then here's the package manager instructions that you can click on, right? And it's important to know about this page as well. In fact, you may want to bookmark it, because one of the other issues is that you often want to check, especially if you're working with Visual Studio Code, you'd want to be checking, am I working with the latest version of the SDK? Because if you scroll down on this page, you'll see that they come out with new versions of the SDK quite frequently. In many cases, they're more minor updates, but you should at least be tracking that if you are kind of manually doing the install, which is more of the way that it would work when you are doing this with Visual Studio Code. All right, so that's step one, is to get the SDK installed on your machine. Then the next step, install Visual Studio Code itself. And again, I put a link to the website where you can go to get Visual Studio Code. Here it is. Assuming you're on Windows, then just click on this button to download for Windows. The download is not very long and the installation is not very long. So that's very, very quick, which is one of the big appealing aspects of Visual Studio Code. And then the last thing that you'll need to work with Visual Studio Code for C# is the C# extension. So I'm going to click on the link there for the marketplace so you can see the details of the extension. However, I would encourage you not to install it from this web page. I'm just showing you more of, here's the web page, and you can install it by clicking on the install button here, but I would advise first installing Visual Studio Code, and then from the inside of code, you can install the extension, which is what I'm going to show you how to do right now. So let's fire up code. I've already got it installed on my machine, of course, so I'm not going to go through those installation steps, but I'll bring it up and show you that if you go here, which is to the extensions icon on the left-hand side, it will show you the extensions in the marketplace, and then you can search right from here. So if I didn't have it installed, I already do, but if I didn't, I can just search for C#, and then it'll show me all of those extensions that match that search term, and the very first one that should show up is the one that you want. And be very careful with these extensions, that you want to look to make sure you're installing the correct one, because as you can see, there's so many C# related extensions. You want the one that comes from Microsoft. So this is something I always like to check, is to see who the author of the extension is. And any of the extensions that come from Microsoft are totally safe to install. What I would be careful about, however, is if you're looking to install some of the other extensions that are out there for other technologies, look at who the author is. And also, if it's not Microsoft or not some big company you've heard of, you might want to check the reviews, because extensions can be dangerous. And that's why I'm giving you the caveat of check really carefully, making sure that it's the right one that you want. And if it's one from someone you've never heard of, at least check the reviews to see what other people are saying about that extension. All right. So that's how you can get the C# extension installed. I'll just show you some of the extensions I have installed, just to give you an idea of how much I use Visual Studio Code. So I have this, which is the tool for extension authors. I have Anaconda extension pack. Anaconda is something to do with AI and machine learning, if you're not aware of that. I told you I do a lot of AD B2C identity management work, so I have that extension. This is due to the work I do with Azure in general. There's something called an ARM template there, so I work with that. I have C++ extensions installed because I still do C++ work on occasion. So there's a lot of things. I have Jupyter Notebooks, again, that's related to AI and machine learning. Kubernetes, I mentioned about how I work with that. So Python, I work with Python. So I do a whole bunch of different things. And the extensions that I have installed are a reflection of how much I use this. All right. Okay, let's get started with applying this to C# now with that extension in place. One of the great things I love about Visual Studio Code, and I'm going to do a Hello World demo here with code, is the fact that you have an integrated terminal. So I'm going to go to the View menu, choose Terminal here, and this is effectively a command line within Visual Studio Code. In other words, you do not have to launch a separate command shell at all. This is a PowerShell window that you get, and all I did was go to the View menu and choose Terminal, and that gets me to here. And then I already have a demos folder that I've created on my machine in preparation for what I'm going to be showing you in this session. It has nothing in it right now. In fact, I did have some demo code I was working on. Let me delete that right now just to show you this. that I just created like a dummy implementation to test out things in Visual Studio before the session, but I just got rid of that. So now I have nothing in there at the moment. And I'm going to create a Hello World.NET application inside of here by running this command. Now, when you install the .NET SDK, what it installs on your machine is an exe called .NET.exe. And this is what you can run in order for you to get started with a very simple .NET application. And you can just run .NET new console. And when you run that, it will give you a set of files. So to show you those files, that would be these. Program.cs file, that is the file that we're going to be starting from. That's our Hello World program. A csproj file, that's just some settings in order for you to be able to work with, effectively compile and run your program, your program.cs. And the obj folder is where your binaries are going to be contained. All right. I don't want to say too much about those for right now because I really want to focus primarily on that program.cs C# file. So let's take a look at that file. I'll type it out and show you what it contains, which is just this console.write line, single line of code that says Hello World in it. All right. So obviously very simple, but I got all that just from running that command .NET new console here. All right. Now that I have that, then I can actually go ahead and get into that directory that I ran this from, this demos folder. And here's how you do this in Visual Studio Code. Visual Studio Code's normal workflow is you just point it off to a folder that contains some files that you want to work with. So I'm going to do that right now by clicking on Open Folder, going to that location, C:\demos, and then selecting that folder and opening it up. And then I can see all the contents of that folder. Instead of looking at it in the terminal, I can look at it right here on the left-hand side in the Explorer window. And there's my program.cs file. And here's my editor for working with program.cs. And one of the things to note is certain keywords. For example, I'll just type in a keyword we're going to be looking at, int, for example, that I can put in a line of code that defines an int like this, int x. Notice how as soon as I type in the x, finish out the variable declaration, it highlights it in blue typeface, right? That indicates to you that that's a keyword. And we'll talk about that in a moment. Now, I want to focus on this right now, which says required assets to build and debug are missing from demos, add them. This is coming from that C# extension. You'll want to say yes, because what it's going to add is this VS Code folder here. And that makes it so that you can work with this environment. And I'm just going to get rid of this line I added in because I really don't want that for the first run of the program. That you can work with now. Visual Studio Code is not just an editor and something that shows you the contents of a directory, but you can work with this actually very similar to the way you would work with it in Visual Studio, which I'm going to be showing you right after this. Right? In that, as long as you've got that little pop-up coming up and you said yes, and therefore you have these assets that were created in this .vs code folder that was added to my demos folder, now all you have to do to go ahead and try running your program is go to the Go menu, Run menu, and choose either Start Debugging or Run Without Debugging, either one. All right. No, the reason why I got tripped up on finding the menu item to choose there is I normally never run it from the menu. I just do Control F5. So I'm a total keyboard guy. I prefer to do everything with keyboard because it's just generally so much faster than finding the menus. But I still see most people I encounter in classes that I teach prefer to go to the menu, and that's why I'm showing it to you from here. But these are the two keystrokes, and here are the two menu items. And if you want to run inside the debugger, you can just hit F5. To run outside the debugger, then you can do Control F5. I'm going to do Control F5 because I know this program is going to work successfully. And if you notice, it's already compiling the code down below here. And ultimately, we'll talk about compilation coming up. But in other words, it's doing the preparatory steps before running the code. And now you see the result. It does say Hello World there. So that's how you can use Visual Studio Code, getting set up with it to be your development environment. Now, I know that was a number of steps, and I know that was kind of fast in the way I did it. So what I'm providing you with in these slides is screenshots of the whole process. So right here is what I was showing you. You fire up Visual Studio Code, you go to the View menu, you choose Terminal, and then that takes you to this Terminal window here. And this is where you can create the console application. I showed you that what you need to do here is run .NET new console. It's right there on the slide. And then after that, once you run it, you open the folder where you ran .NET New Console. In my case, it's C:\demos. And then you have to wait a few seconds for this to come up, by the way. Assuming you've installed the C# extension, you have to have the C# extension installed, by the way. If you don't have this installed, you're never going to get this little pop-up in the lower right corner that says required assets to build and debug are missing. And that will take a few seconds. Sometimes you might have to wait up to, like, I'd say 20, 30 seconds before it pops up. When it does, click on yes. And then once you do, then you will have this VS Code folder emitted into your project. And you'll already have, from running .NET New Console, this command, you'll already have a program.cs file there. So you can just click on it on the left side to open it up. And then you just go to the run menu, choose run without debugging, and you'll see the execution result as I demoed. So I intended these slides to be a means for you to recreate what I'm doing in the demos if you want to be able to come in and try this out. All right. And by the way, what I'm showing you right now is not in those instruction pages from the workshop. These are all coming from slides that I personally wrote in order for me to show you the steps involved in starting from nothing and then going all the way up to running your first Hello World C# program. Now, the development environment that I normally use is Visual Studio. And there are a number of different versions of Visual Studio. So let me go to the Visual Studio webpage here to show you this. And when this pops up, here we go. This is the Microsoft page for Visual Studio. I want you to be aware, first of all, that the 2022 edition is the latest one. I still see a lot of people out there who are using Visual Studio 2019 or even 2017, the two preceding versions of Visual Studio. But again, if you're attending this workshop, I'm assuming that you are brand new to C#. And since presumably you're starting from scratch, why not, again, be on the latest development environment, just like I'm encouraging you to be on the latest version of .NET. So the latest development environment version is Visual Studio 2022. You can download it from here by clicking on this drop down. Now, you have to know which one of these to download. So I'll tell you the story of these three. If you do not have an MSDN license and you don't plan to acquire one, then choose Community. Community is entirely free. You do not need any license in order to use it, as long as you're not using it for commercial purposes in a company of more than 5 employees. This is fine, free to use. All right. If you do have an MSDN license, then I would encourage you to go with either Professional or Enterprise. Professional being the most, the Enterprise being the most fully featured version, but most expensive. Professional is in the middle. It has more features than what you have with Community, but not everything that's in Enterprise. And I'll just show you the details. I put a link onto this page of the details of a MSDN subscription. And you can look at the difference in pricing between Pro and Enterprise. And you see how wide the gap is in terms of features. My advice would be, if you're starting brand new to this and you don't have an MSDN subscription, try this out first, play around a bit with it. I'd start with Community. And if you find yourself really getting into this, you think you want to become a professional C# developer, then I would encourage you to get one of these two versions. And personally, I would say, unless you really have a need for something that's in Enterprise, I'd go with Professional if you're going to do a paid version, because the gap between these two is not humongous. It's that Enterprise has a few features. If you absolutely need them, then of course, you have no choice. But given the fact that it costs so much more, I think it makes more sense, if you were going to do a paid version, to look at using the Professional version. But you need to install that. And by the way, if you install Visual Studio, you don't need to do any of these other steps. You don't need any extensions. You don't need to even install .NET 6. That will all be installed automatically as part of the Visual Studio installation. So it's the installation part, in terms of the steps involved, is easier if you're going with Visual Studio. All right. Now, the caution I got to give you, though, is that Visual Studio takes a long time to install by comparison with Visual Studio Code. And it has a lot more hardware resource requirements. You have to have a lot more free space on your drive. And also you have to have a more powerful CPU configuration. You can look online to see what the CPU specs required are and the amount of required hard drive space. But be aware, Visual Studio is a resource hog compared to Visual Studio Code. So that's why I'm giving you both options depending upon what your situation looks like. All right. Now, here's how to get started with a Hello World program in Visual Studio. And then after that, I'm going to get into those pages that will talk about the details of C# itself. Once you do the installation, then you will have, here on my machine, I have Visual Studio 2022. And rather than having to run like .NET New Console, what you will do is come into here and create a new project. So you'll click on the lower right corner where it says create a new project. In the dialog that comes up after that, very important, you need to make sure that you are choosing the right project template. I would encourage you, since we're going to be working only with C#, to pull down this drop down and choose C# there. And then the one you'll want to choose, the template you'll want to choose is console app and C#. Make sure it says both of these things, both console app and C#, because there are other console apps that are not C# that are in the list of templates. Also, it's possible for you to see console apps that are for other languages altogether. And there's plenty of other types of applications for C# that are not what we're going to be using here. For example, here's one for ASP.NET Core Web API. Notice that's a C# one, but it's not what we're looking for. We're looking for console app and C#. And then we're going to click on next. All right. I'm going to put this into the demos folder. I'm going to call this intro VS demo to reflect the fact that it's Visual Studio, or you can call it whatever you want in reality. I'm going to click on next again. And then there's only going to be one option here for Visual Studio. One option you should care about, I should say. Choose the default. .NET 6 long-term support. These other ones are older versions of .NET. Since, again, I'm assuming you're starting from scratch, why not target the very latest? So just stay with the default there and click Create. And once you do that, then that will take us into the world of Visual Studio, and I'll be using what is here in Visual Studio for the remainder of this session, showing you what the steps in the instruction pages tell you to do. All right, once again, same thing you saw in Visual Studio Code. I have a program.cs file. Notice also on the right-hand side, I have a Solution Explorer that shows me what files I have inside of this project for Intro VS Demo. And here, all you have to do, nothing to run from the command line at all, do a Control F5, or if you want to run it from the menu, you can go to the debug menu and choose either start debugging or start without debugging. So once again, I'll choose start without debugging, and you'll see a console window pop up, and you'll see the results get written out to it. And there's your hello world with the results being shown there. All right. So that's an example of how to get started with either one of the two major development environments. And like I say, for the remainder of this, I'm going to be just using Visual Studio. Once again, I created screenshots so you can replicate everything that I just showed you by walking through these screenshots. Here's what I did. Create a new project. I filtered. Actually, I just pulled down this drop down and filtered, so I'm only seeing C# options. You can also filter by typing a search string at the top, for example, console, so you only see the ones that have console in the name. And then here's what I just did, Hello World project with whatever location you want it to go out to. And then choose the default here, click Create, and then once you get in, start without debugging. That'll launch the program. And that's Hello World. All right. So I want to go back to those instruction pages that I had over here, and we'll bring that up, and then we'll talk about what you want to do. Okay, so we've already done this. This is the instructions for entering the code into the .NET editor. Well, we're not going to use the .NET editor. I mean, you can do that if you want and pressing the green button, but we saw we're going to do this from a development environment. Now, what happens if I mess something up? If I were typing this in manually and I made a mistake, for example, the console, the C in console is supposed to be uppercase, but I made it lowercase, you'll know right away. Because one of the things that they feature here is dynamic compilation, where they flag it. Before you even try to do a build or before you try to run it, it will show you almost immediately. Some cases there'll be a second or two lag, but here's where it indicates the name console does not exist in the current context. So I need to make that uppercase C there in order for it to work properly. All right, so that's an example of the error message that you're seeing there in that lab page. And once you correct it and then run it, then you'll be fine. But let's say you make another mistake. So this is referred to as a string literal, effectively a constant string. And that's if I use double quotes. If I change this to single quotes, I want you to see what happens. Single quote would be for a character. But now if I use single quotes, and it already puts in the end quote, that's why I ended up with two quotes there when I typed the single quote. The problem is because I'm using single quotes, it thinks that I'm just going to have a single character. and I'm putting multiple characters in between the single quotes, this is where I get this error, too many characters in a character literal. So if you want a string literal as opposed to a character literal, you need to use double quotes. So I'm just putting the double quote in. Again, every time I type in a double quote, it puts in 2 quotes. And that's just an editor convenience because it's trying to create a string for me, and it's trying to make it easier for me. I need the end double quote now. And that's why they put in double quotes when I type in a single double quote. It puts in 2 of them for me because it wants to end the quote for the string. So I'm just taking that off and correcting it back. And everything now is all good. It will run again just as it did before. All right, so that's what this bit of the lab here is telling you to do. And then they're also telling you some common mistakes that programmers make. So the convention is this part, which is the class name, should always be initial uppercase. This is called Pascal casing. Everything else after that is lowercase unless it's a multi-word name. If it's a multi-word name, the first letter of each new word is capitalized. Looking at this right line, this is called a method. And think of it like a function. And it uses the same casing conventions. Initial uppercase, if it's a multi-word name, which this is, the first letter of the new word is capitalized there. So the L in right line is capitalized. All right. So you see that that's a mistake that people sometimes make, is getting the casing wrong. Also forgetting the double quotes. If you leave off the double quotes altogether, I'll show you what happens there, you will get an error. The name hello does not exist in the current context. So I'm going to reverse that back to what I had before a moment ago. And now it is also telling you to comment out the previous line of code and then add new lines of code. And those are these new lines of code here. I'll show you how to comment something out in the editor. One way to do it is to use 2 forward slashes there. And that is the equivalent of a comment. In fact, I'll show you multiple ways to do comments. That's referred to as a single line comment. If you have a comment that spans multiple lines, like let me put in another console.write line here just to illustrate this. And I'll say hello again, for example, like this, right? And I'll take out that comment that I was putting in. And I want to comment both of these lines out. Another way to do it is to put in /*, and then on the back end, when you want to stop commenting, */. And that comments everything in between these delineators for the comment that you see here, right? Now, I'll show you a really quick editor way that I always do the comments. Because I'm a keyboard guy, I just like to show you these tricks right up front. If you want to comment out multiple lines like this, you can highlight the lines and then either do this, which is click right here on this toolbar item if you're using Visual Studio, or if you are doing it, if you're doing it manually, then you would have to manually put in // on each line. But if you're a keyboard person like me, you can use Control-EC. So, and it shows you right there on that tooltip item when you hover over it. So if I wanted to comment out both these lines, highlight them both, do Control-EC, both of them get commented in one go. If you want to uncomment, then that's this toolbar item here. Uncomment the selected lines. Control-EU is the equivalent. So I can do Control-EU, and the lines are, oops, I hit the wrong key, sorry. So I have to highlight the lines again that I want to uncomment and do Control-EU, and that uncomments them. So that's the quick way that I normally do it. It's not mentioned in these instruction pages, but just so you're aware, that's how I would comment those lines. All right. Okay, so now let's do the next bit. So I'm going to comment those lines out like it's instructing me to do. And I'll put in this code right here, which is a little bit more extensive code where it writes out congratulations. This is the new thing that it's showing you, console.write as opposed to write line. What write line does is it basically terminates the line. And write does not do that. Write is if you want to just add something and you want to write something out to the console, but you don't want to terminate the line. Then use console.write as opposed to write line. And then we're doing one more console.write here to say you wrote your first lines of code. So notice all of these are console.writes, which means it's all going to get crammed together on a single line in the console when I run it. And that's what I want to show you. And that's exactly what you're seeing here. Congratulations, you wrote your first lines of code, but it doesn't do line termination afterwards. That's the difference between write and write line. Okay. So that's all what this is going through right here, is explaining all of that. And now I'll continue on to the next bit and talk a little bit about back up and talk more big picture. I've already kind of explained this to you, like what C# is. It's a programming language, and a programming language is basically allows you to write a set of instructions that you want your computer to carry out. So that's a very apt description of the first sentence of this paragraph here. Now, different languages have different syntaxes. So one of the keys to learning C# is learning the syntax. An example of syntax is things like putting a semicolon at the end of statements. C# requires that. Other programming languages do not. For example, VB.NET, you don't put semicolons at the end of statements. Another bit of C# syntax that's very critical is that C# is a case-sensitive language. So as you saw that already a few moments ago, if I change the C in console to initial lowercase, we get compilation errors. Why? Because C# is a case-sensitive language. So this is all part of the learning process of the syntax of C#. Now, compilation, what that is the process of taking what you are writing, the C# syntax, and turning it into executable instructions that are understood at a lower level that can actually be run on your machine. Because your computer doesn't natively understand C#. What you have to do is somehow transform that into something that the computer does understand, and the process of doing that transformation is called compilation. And that's what's happening internally when I run the program. It's compiling first and then running it. If you just wanted to from Visual Studio to compile by itself, you can go to the build menu and choose build. And that will just run the compiler. And notice in the lower left corner, it indicates build succeeded there. And if there were any errors, it would be displaying out those errors in this error list window that you see up on my screen there. All right, so that's how that piece works. And then this goes through what syntax is. Well, I just gave you some examples of syntax, some of the bits that you need to know about. Things like the semicolons at the end of statements, the parentheses that you need to use to indicate a method call. That's all part of the syntax. Right? And here is just a bit more about what happens when you run your code. The fact that we are using literal strings here. These are called string literals, as I mentioned. And I'm going to be exploring that a little bit more in the next few minutes. Right? I mentioned to you about how console.writeLine is a method. Console is called a class. Right? And in order for you to invoke a method, what you need to do is, in the case of the console, you need to use the class name dot and then the method name. So here I say console.write. Okay. And don't worry if this is all overwhelming and you're brand new to this. It's all part of that big learning curve of C#, but you have to start somewhere. And this is the initial starting place that we're looking at. So this summarizes the basic rules that we've been going through. Now, if you want to understand the execution flow, which is critical, then you need to know that your code instructions are executed in order, one line at a time, until there's nothing more to execute. And some instructions require the CPU to wait before it can continue. Other instructions can change the entire flow of the execution. And we're not going to have time to really get into those other instructions, but you should be aware of that. All right, let me click on this continue. And then here's a bit of a challenge now. It tells you to write code in the .NET editor to display these two messages. And by the way, there's no single right answer for this. So it says this is the first line, this is the second line. In fact, let me code that up for you really quickly so you can get an idea of how one possible solution to this, given what we've talked about so far. So you could do, for example, a console.write and do the first part and say, this is the first, and then let's see, there's a space. Yeah, there's a space and semicolon. And then because I want to terminate the line here, I'm going to use console.writeLine and then say line like that, right? And semicolon. And then if I want to write out the second line, again, I can do a combination of console.writes and console.writeLine. So I can do a console.write and then specify a part of the string that I want to write out. And I can say this, I'll just write out one word, and then console.writeLine, assuming that I want to write out the rest of the string here, I'll put in the space, and then I'll say is the second, oops, I got to put in a space there, second line, like that, right? And when I run this, it should be the equivalent to the output that you have on the web page there. So let me run that, show you. Sure enough, the exact output that the instruction is asking me to give. Oh, except I didn't put the periods at the end of the lines, although that's pretty trivial. But I basically created that output. This is one possible answer. But there's many other possible answers to the challenge as well. For example, I could say console.write like this. And then I could say first here, space. And then I could take off this part of the string from here and make it look like that. In other words, I can do multiple console.writes more than I had originally, but yet still get to the same end result. And that's what you're seeing there. All right. And because it's bugging me, I will put in the dots at the end of the sentences, just so it exactly matches what you have there in the challenge. There we go. All right. So that's an example of what it's showing you there in the challenge and how to accomplish that. All right. Here they give you the solution. Again, there's many solutions. I just did one possibility in the demo, but they have a different one here in the example that's shown on the web page. All right, let's do the knowledge check. So this is the quiz I was telling you about. First question, what is the primary job of the compiler? Well, the compiler primarily locates spelling mistakes in your code. To an extent, it does that. If you make a mistake, for example, spelling console, it will spot it. But that's not really the primary purpose of the compiler, right? The compiler primarily reformats your code. It doesn't do that. The compiler primarily executes your code. Doesn't do that. No, you have to execute it after compiling. This is what the compiler does. It primarily converts your code into executable format that your computer can understand. Which of the following statements is true about C#? C# is case insensitive. That's wrong. It's case sensitive. Console is a method and WriteLine is a class. No, it's the reverse. WriteLine is the method and console is the class. You use double quotation marks to create a literal string. That is correct. And the last one, if you make a mistake when writing your code, you have to delete it and start all over. Clearly, you do not. In fact, that would be cumbersome if you did. All right. And what is wrong with this line of code? Looking at the line of code that you see here, right, with console.WriteLine, what is wrong with me? The L in WriteLine, it says, should be lowercase. That's wrong. It's got to be uppercase. I told you the casing convention is the beginning of a new word is uppercase. It's missing the semicolon at the end. Yeah, that's the one. I told you earlier that semicolons need to be at the end of statements. And this one is wrong. The string should use single quotes. No, it has to use double quotes. Single quotes is for a character literal, not a string literal. And a comma should be used instead of a dot between console and WriteLine. That's totally wrong. You want the dot, not the comma. And I'll check the answers, proving to you, yes, it is correct. And I'll continue without saving the progress. You see the little green highlighting there indicates all my answers were correct there. Okay, let's move on to the second thing that they want you to do in this workshop. So I'm going to go back to my slide deck here where I have the links to the web pages for each piece of what we're installing. That's the installation bit right here, the workshop steps. This one is for storing and retrieving data using literal and variable values in C#. So let's walk through this. All right. Oh, goodness. There we are. So this will take me to the web page for that. And here are the learning objectives: to create literal values for 5 basic data types, declare and initialize variables, retrieve and set values in variables, and allow the compiler to determine the data type for a variable when initializing. So let's go on. And here's the intro. Again, I'm going to skip through that. You guys can read through all that verbiage in the intro. The learning objectives, I basically told you what we're going to do. And let's get into it. So let's talk a bit more about literal values. Well, you've already seen a literal value, a string literal, right? The thing that makes a literal is that it's a hard-coded value that doesn't change. It's a constant value, basically. And since you've already seen an example of that, there's not too much more I have to say about that. This is an example, though, of printing out other literal data types other than a string. For example, if you want to print out a character, I'll show you that. Because I've shown you so far not to use a single quoted literal, but here's one where I need it. Let's say I want to write out the character A. I just need to use single quotes and specify the character A in between. And that is now a character literal. I'll run it, show you that it writes that character A out to the console window. So that's what that one is showing you. This you've already seen before, the double quoted string character literal, string literal, excuse me. And if you enter this following code here, it shows you, and I did this before, with single quotes, but with a string, it will be an error because single quotes imply a character literal, not a string literal. All right, what about an integer literal? Let me show you that. So I'll do a console.WriteLine of an integer literal. I'll write out 1, 2, 3. This is a integer literal now. So I'll run that. And sure enough, it writes that out successfully to the console window there. And that's what this bit is showing you here. Now, what about a decimal literal? Here's what I mean by a decimal. Decimals are often used when you want to do things like write out a currency value where let's say, you know, like you have lunch, and these days lunch costs like, I don't know, $10, maybe 50 cents, depending on where you buy it and what city you're in. If I do 10.5 like this, then, and you want to indicate that it's a decimal value, you need to put in a format specifier, because otherwise it won't treat that as a decimal value by default. So you can put an M in after the value, and decimals have 2 digits after the decimal point. So that's what we have here. I'll just run it and show you. Sure enough, that's fine. That is considered to be a decimal literal, and that M specifier is an indication of that. By the way, you can leave off the second number if it's 0. So you can say 12.3 as is done here, and that was also a valid decimal literal. All right. What about Booleans? Booleans are true-false values. So I can write one of those out, a literal, by either just saying console.writeLine and writing out either true, like this, or I can write out false, one or the other. Right? And notice it's also a language keyword, so I can make this false, and it turns blue. Language keywords turn blue, so that's an indication that it is a keyword in the language. The fact that it turned blue when I typed it in. So you're now starting to see some data types. We had the string data type from Hello World. We have a character data type, an integer, decimal, and false. Those are the ones that we've introduced so far. So why is this so important? Because C# is very much what is called a type-safe language, which means if you pass something in to, let's say, a method where it's expecting a certain type and you pass the wrong type in, it's compile time error. It will be flagged, right? And I'm going to show you some examples of making some compile time errors where we run afoul of typing coming up. All right, so this little bit here is just showing you what these values may look like with their string literal equivalents, where notice there's a distinction, and this is why typing is important. This is what this is trying to illustrate. You can get the same end result out on the console window, for example, when I wrote out the integer literal 1, 2, 3, if I write out the string literal 1, 2, 3. But be aware, these are different, right? These are fundamentally different, even though they yield the same output. In both cases, I'm seeing 1, 2, 3 get written out to the console window. The difference is I'm passing a string in here, I'm passing an integer in there, and they're totally different data types. Similar thing is true of this one. When I write out to the console, let's say, false as a string, as opposed to writing it out the way that I did there with the Boolean literal, then they yield the same output in the console window, but they're totally different in terms of what's going on internally. That is of type Boolean. This is of type string. And that is a very critical distinction that you need to know about, and that's what it's telling you in that example there. All right, and here are the 5 major types that we've introduced so far: string, character, int, decimal, and bool. Okay, now let's talk about, instead of literals, which are constant values, let's talk about variables. Because in real world programs, not everything is constant. You typically want to have a data item where its value can change. And that's what a variable is. Right? So here's an example of how to declare a variable. Let's say that what I want to do, in fact, just so you can avoid fixating on what I have here, I'm going to just comment all that out, and I'll write some new code down here where I want to create a name string like this. The way to declare it is to specify the type. This is why you have to know about those 5 types we talked about a moment ago, and then whatever name you want to use for that variable, like this. And then I could assign that to something. I can assign it to Ron, like this, at one point in time. I can assign that name to something else later on, right? I can assign it to Ronald, like that. And because it's variable, it's perfectly permissible for me to assign it and then reassign it to something else. And then now we'll use it in the context of again, a console.writeLine call like this. And I'll go ahead and run the program and show you that, yes, the second assignment I did is the one that is displayed because I changed the value via that second assignment there, right? And this was the initial assignment. In fact, let's do this. Let's put a console.writeLine in between the reassignment there so that you can see both get written out to the console window. All right, and that's what we have. So that is a little bit about declaring the variables. And then here are the variable name rules and conventions. So this is a very good summary, by the way. And when you're first starting out with working with C#, these are all things that you need to know. So the variable names must not have a special character. For example, I cannot put a pound sign in front of the variable name there. If I do, immediately the compiler flags that. If I try to put a pound sign at the end of the variable declaration, same thing. You cannot put special characters like @ or pound signs in with a variable name like this. Compiler won't allow you to do that. Now, while the compiler doesn't enforce it, it's more of a convention. Your local variable names like this should start with lowercase as opposed to class names and method names, which start with initial uppercase. This uses what is called Pascal naming convention, where, Camel casing. This up here, this was Pascal casing, where we start with initial uppercase. The first letter of each new word is uppercase. This is Camel casing, where you start with initial lowercase and the first letter of each new word is also uppercase. So if I wanted to, for example, have a first name variable instead of name, I would start with initial lowercase, and then because this is a multi-word name there, I need to then make the first letter of the new word be uppercase. And I'm going to change this all to that really quickly, like this, right? So this is the proper naming convention that you should be using for variables. Again, the compiler lets you get away with violating this, but it's the well-known naming convention or casing convention in C#, and you should be following that. All right. So variable names must begin with an alphabetic letter and an underscore, not a number, and then you put in the type of the variable and the name of the variable that you want to use. You cannot use a language keyword as a variable name. So for example, I cannot have a local variable name called string. That results in an error, as you are seeing here. So you're getting an error right away if I try to call the variable the same name as the type or as the name of any type. In fact, I couldn't even do this, just to show you. I cannot say I have a variable called int that's of type string. Notice how I'm getting an error when I do that, because int is a keyword and I cannot declare a variable. Now, if I call this int 1, then the compiler's fine with that, right? But I cannot use a language keyword, because if I use int 1, it's no longer a language keyword there. All right. And here are some of the other rules as well. I'll leave it up to you to go through every one of these. I'm not going to walk you through every single one. You guys can read up on that. But I'm showing you the highlights of the big things you need to know. Here's a bunch of examples of variable names that are all legal and following best practices, as you see there. And notice this one where this is a 3-word name. So again, initial lowercase, camel casing, initial lowercase, first letter of the next word is uppercase, first letter of the word after that is uppercase there. All right. Now, that is one way to declare a variable. Now, what about if I want to assign a value to it? Well, you saw me do that. We covered that a moment ago. And you can attempt to improperly assign a variable. In fact, here's an example of an improper assignment where on the left-hand side, I have a string literal and I'm trying to assign it to the variable. You cannot do that. Remember, string literals are not changeable. But if I have a variable on the left-hand side, that's legal. So in other words, what I have up here is legal because first name is a variable. But double quoted Bob is not a variable. That's a string literal. So I cannot assign it to anything because it's not changeable. All right. And if you try to do that improper assignment, then you are going to get an error. What about if I mismatch the types? For example, if I define an integer like this, x, and then I try to assign a string to x, like I'll just do it in line like this, that's not legal. Because the right-hand side is a string, the left-hand side, we declared x as an integer, you get this. Cannot implicitly convert type string to int. So that's why we're getting the error there that we are. Right? So that's what this section is telling you. And what about when you want to retrieve the value? We just use it. And I did that here. We wanted to retrieve what the value of the variable first name is at this point in time. We retrieved it at that point in time. We just use that variable name, for example, in a call to something like console.writeLine. All right. And then here's where an example of reassigning, and that's just what I was doing in the demos. If you want to initialize the variable, you can initialize it this way, declare the variable first and then initialize it after, or you can do this as well, which is what I was also showing you a moment ago. Right when you declare it, you can initialize it. And that's legal too, and it still compiles and runs just as well. In fact, normally, if I already know the value I want to initialize it to right when I declare the variable, I normally do it like this, as opposed to doing it with 2 separate lines. All right. Okay. So that's what this example right here is showing you. And here's the recap. So these are just the rules. You must assign a value to a variable. Oh, and I didn't show you this. This is very important. If you try to use a variable without giving it a value first, that is an error. So for example, let's say I try to put a string last name in like this and write it out. It's going to be an error. You have to assign a value before it is used. And I want to show you the error message. Use of unassigned local variable last name. If I assign a variable to it, like my last name, Sumita, then error goes away, right? And then everything runs successfully from there. So that's a very important piece that I want to make sure I drive home, because that's actually different from some other languages where they assign a value to a variable by default like that. They do not do that if it is what is called a local variable. All right. Okay. I want to get into implicitly typed local variables. So one of the other things you can do is, instead of explicitly typing the variable like this, you can use what's called an implicitly typed variable by using the var keyword when you declare the variable. Right? By using var, what it means is that you're letting the compiler infer the type of the variable from the initial assignment. Right? But very important to be aware, if you use var, it is still strongly typed. It is still of type string. And you can see that by just hovering over the variable in the editor in Visual Studio. It will show you that that is a string. By the way, when it says string question mark, that's referred to as a nullable, which is way beyond the scope of our discussion here. Just focus on the fact that it's string. All right. But there's something called the nullable types within C#, very advanced thing, which I'm not going to even bother to cover right now. But that's why it's showing you the question mark afterwards. But think of it for right now as this is really a string, and that's what it's inferring it to be. Okay. Now, a couple of things about this. It's going to infer the type from whatever the initial assignment to the variable is. And if you try to change that later on, for example, if I try to assign last name, which is really of type string, to an integer, that's a compile time error. It's going to flag it because it's trying to assign it into a string, and that is not legal. So you need to be aware of that. Also, if you try to use var but do not provide an initial assignment, even if I don't use it subsequently, I just do this, it's an error, right? And notice it's a different error from what I had before, where I had the error of I hadn't assigned a value and I was trying to use it. That's not this error. This error is because I'm using var specifically and I have not yet assigned a value to it when I declared it. That's an error. And you see, implicitly typed variables must be initialized. That's what that's telling you there. All right. So you could think of this as primarily a convenience so that you don't have to explicitly say on the left-hand side what the variable type is. You just say to the compiler, I'm turning it over to you. You figure it out by what I'm assigning it to on the right-hand side. All right. So that's what they're showing you here. Here's an example of an implicitly typed string variable. Why is it string? Because that's what we're putting on the right-hand side. And looking here, here's another example where we are assigning it to a string, then we're trying to reassign it to a decimal. That fails, and fails at compile time because, again, message is strongly typed, and based on its first assignment, it's of type string. When you assign it to a decimal value, it becomes an error. And then over here, a bit about how you can only use var keywords, the variables initialized. I just demoed that to you. You cannot do this, for example, right? And even if you wanted to initialize it on the next line, that's not going to work. You have to, when you declare it, initialize it. Now, big thing, why use var? I use it primarily in two cases. Case number one is where the right-hand side can be very complex in some scenarios. And I don't care what the underlying type is. That's when I use it. Another case scenario is there's this thing in C#, very advanced thing, which I'm not even going to bother to cover here. In a more advanced C# session, I'd be happy to cover it, but called anonymous types, where they're literally types with no name. There you have to use var. Other than that, I don't tend to use var because I think it makes the code less readable. I think it's a whole lot easier to see what's going on if you look at a declaration like this, as opposed to one that looks like that. However, I will tell you, there's a lot of debate that surrounds this. And there are some people who say you should use var always for all variable declarations. And I'm going to tell you there's no right or wrong answer to that. I will tell you this instruction, set of instructions, though, does say we recommend you continue to use the actual data type name when you declare variables. I agree with that, especially when you're first getting started. I would prefer to see you use the explicitly typed variables as opposed to implicitly typed. But in real world code, you will see this a lot where people use implicit typing everywhere. That's more of a religious debate than true factual debate where there's a winner or a loser on one side of that or the other, right? But in any case, that's what an implicitly typed variable is. Okay, so here's another challenge. Delete all the code. It says write the code in the .NET editor to display this message. So once again, here is the challenge where you want to write out these bits. Hello, Bob. You have 3 in your inbox. The temperature is 34.4 degrees Celsius. I'll just do this really quickly. I'll copy the whole string into my Visual Studio session here. Here's the entire string, but we want to write this out. Because again, when I type in double quotes, it gives me 2. There we go. And I want to write this out, but I want to do this with using actual types that I define. So for example, I could define an integer number like this, or message, num messages, I'll say. And I'll set that to 3 because I want to show you how I can construct this string from data types that I put into my code. I'm going to have a string called greeting. I'll set that equal to hello, Bob, that part of the string there, like this. And then for this decimal, I'm going to call this decimal and degrees. And set that equal to 34.4. And then put the M afterwards to make it a type decimal. And then now, in order to construct the string, I could do in fact, I'll do a string message equals, and then it would be greeting. And you can concatenate the string together by using pluses. This is one technique. So here's what I want to start with, hello, Bob, right? And then I want to say, I'll do the next part of the string, you have. Oops. In fact, let me make it a little simpler. I'll do hello, Bob, exclamation point, you have. And then for the 3 part, I'm going to write out whatever the num messages is, like this. I can say num messages plus now, and then do the next part, which is in your inbox dot the temperature is, and then again I want to concatenate on to the string the degrees, like that. And then I want to put Celsius on the back end of that, right? The Celsius part of the string, like this, dot. And that is an example of the message string that replicates what we have here. In fact, I'm going to comment this line out, and I'm going to write that out to the console to prove that this should do what we want. So I'll do a console.writeLine of message there. All right. And let's run it and verify that what we see is, hello, Bob, you have, 3, I have something extra there. 3 messages. I said 3 in your inbox. So I just didn't put a space. There we go. There we are. So this, and I didn't put a space in after the 34.4. So I need that before the Celsius part. Just put in a space there, and then I've replicated and done the challenge. So again, there's many ways to do this challenge, but the main part is to show you using in the output variables these strong types for the string, the number, and this is being an integer, the number of messages, and the number of degrees. And that's what the solution, which is on the next page, shows you how to do, like this. All right. Okay, let me go on, just do quickly the knowledge check, and I got one last quick section to do, and then we'll wrap up. So let's check our knowledge. Which of the following variable names should be avoided? Yeah, this one, right? You cannot have a special character in a variable name. What is the problem with this line of code, var message? Well, the big underlying problem is use of the var keyword without initializing the variable. Which of the following lines of code creates a variable correctly? Well, looking at this is wrong because this is of type decimal on the right side, and we're saying int on the left side. This uses string on the left side, decimal on the right side. That's wrong. This is correct. Decimal on the left side, the M specifier on the right side, that is correct. Check the answers and continue without saving progress. There we go. You see all my answers are right. So we're good there. One last one to do, and then we're going to wrap up. And that's basic string formatting with C#. And I'll bring that part up. And this one walks you through some exercises. These are pretty quick, so I can do these relatively quickly. A string that contains tabs, new lines, and other special characters. A string that contains Unicode data. One that combining a string via concatenation. I just showed you that a second ago, so I've done that one already. And then a new string via what's called interpolation. That's the big one I want to get to. So let's quickly go through these. Again, I'm going to skip the intro. You guys can read all of that. Here is how you escape, or how you use character escape sequences and verbatim strings. So if, for example, what you want to do is escape the meaning of a special character. For example, let me do this. I want to get a file path. I'm just going to copy that right out of the Windows Explorer. And I want to write that out of the string. I'm going to show you what happens if I literally take that string and put it into a console.writeline like this and stick it in there like that. I get an immediate error. And the error notices unrecognized escape sequence. And the reason is backslash has a special meaning. So if you want a true backslash, you have to proceed. You have to use double backslash. You have to precede whatever special character it is with backslash. So because I want it to literally have a backslash in the string, I have to put a backslash in front of it, if that makes sense. So now when I run this, it should show me C:\\backslash demos, and there should be no errors. So that's an example of a special character. Another example of a special character is if I want to put a tab in front of this, I would use backslash and then T indicating the tab character. And now what I should see is C:\\backslash demos is indented when I run it. And that's exactly what we have. Notice how it's indented by one tab because I put in the backslash T. Otherwise, if I just put a T there, of course, it's going to literally render a T out there as part of the string, and that's not what I want. So that's the purpose behind that backslash. All right, and this is used for special characters. There's another way to write out a path. In fact, let me just go a little further a little deeper so that I can show you a more complex path where it would be kind of cumbersome for me to write out backslashes everywhere where I want a backslash. So rather than having to go through and do double backslash everywhere, you can do this. This is putting an @ in front of the entire string, and that means interpret the string literally. In other words, do not give any special meaning to the backslash within that string. And now this will work fine. It compiles fine, and it runs fine as well there. Right? And that's basically what this is walking you through in the lab manual here. The character escape sequences, I talked about the backslash, and I gave you the example of putting a backslash in. If you wanted a double quote, for example, within a string, because the double quote would delineate the end of the string here, you need to precede it with a backslash. And then I also showed you this example of a path. This is an error, right? Unrecognized escape sequence. But you could either put double backslashes in everywhere, or you can format the output you can put the @ in front of the entire string in. Right? So that's what was shown there. And I showed you an example of this, putting in \T, for example, within the string to get the tab character. Putting that @ in front of the string is called a verbatim string literal. So that basically means whatever text you put in after whatever string you put in after that @, it's going to be used verbatim. Like in this console.writeline call where I even have line breaks within the string, that's literally what's going to get rendered out there. And then here is how it can be used in a path, the way I showed you. What about Unicode characters? Unicode being for supporting other languages which have character sets much greater than ours. I mean, in English, we only have 26 letters in the alphabet plus a bunch of special characters, but not really all that many. What about for other languages like, for example, Asian languages where the character set is huge? Then you can use the backslash with the U and then the number of the character in UTF-16 format, right? That's Unicode. Okay, and this is showing you to generate, for example, Japanese characters that correspond to this. You have to know the Unicode character sequences for the Japanese characters that you want to emit. All right, and this is just a recap of what we talked about. In fact, if your system supports it, you can actually even see the Japanese characters if you write out the string the way that was illustrated above with the \U and then the code for that Unicode character. All right. Here's an exercise on string concatenation. Well, I just did that in the demo. I showed you that you can concatenate a string together by using plus. In the course of doing that demo, I showed you that. And now one last thing I want to show you, which is how you avoid having these intermediate variables like this and how to do this in a more elegant way. And that's string interpolation, this last piece. Let me just do it in my demo. What I'm going to do is I'm going to redo this example that I did here of this string, but I'm going to do it the way I would normally do with string interpolation. Let me just do a console.writeline and I'll write the whole thing out. String interpolation involves putting a $sign in front of the string, not an @ but a $sign. And then you can mix in the actual text you want to have. So hello, Bob, you have, and I'll put that part in, right? And then when you want and have an expression like a variable that's evaluated, you put it in curly braces. So if, for example, what I want to put here, which is the value of num messages, I put that inside of curly braces. And what that tells C# is interpret this, to whatever the actual value of the variable is, stick that into here and within the string. And then I'll say you have, let's see, in your inbox box like this. I'm trying to replicate exactly what you have there. The temperature is, let me go to full screen within Visual Studio so you can see it all on one line, is, and then I'm going to say that I want to do open curly brace. And then within here, I can specify degrees. That. And then I need a semicolon on the back end of the line. And I got the variable name wrong there, messages. There. And then also on the front end of this, I don't need this hello Bob you have part because I already have that in my greeting variable. So I can replace that with just open curly brace greeting. Now what will happen is these curly braces are placeholders. So whatever this evaluates to will be substituted into the string. And it's a way of building up the entire string there. And I'm going to comment this line out because I don't have a message variable anymore. All right, that's it. In fact, let me move this down so you can just see it all on one easy view. I'm going to run this. It should replicate the string that we have up above. And there we go. Hello, Bob. You have 3 messages in your inbox. The temperature is 34.4. And once again, I forgot the part about degree Celsius and the period on the end. All right. Now we've exactly replicated the original string, but using this. Oh, I misspelled Celsius. There we go. Exactly replicated it, but in a much more elegant way than what I did up above, I would argue. In that rather than having to put in all the plus signs and everything, I just put $1 in front of the string, and then I can put in curly braces expressions that I want them to evaluate, and whatever those curly braces evaluate to is substituted into the string, and that is called string interpolation. And that's the last thing that the instructions tell you about, right? Avoiding intermediate variables, combining verbatim literals and string interpolation. So here's the recap. And then finally, the challenge. I'll leave it up to you guys to do this challenge because I'm getting close on time. But it shows creating 2 mandatory lines. I just want to get to, and then the second part of the challenge is using the character escape sequences verbatim strings. But I've been demoing all of that. And then here's the solution on the next piece. So I'll leave it up to you to look through that. Let's do a quick knowledge check. And then I'm going to do a wrap up, and then we're all done. So which of the following escape sequences would you use to add double quotes to your literal string? Well, that would be a backslash in front of the double quote. That's that one, right? This says, which of the following lines of code correctly uses string interpolation, assuming that the variable value is in the string? Well, you need a $sign in front of the string, remember, if you're using string interpolation, so that would be this one. And then finally, your embedded Unicode characters in your strings present special message in Thai. However, the message is only displayed as question mark characters. What happened? You're missing the \u escape sequence in the Unicode characters, and that's not it. You use the wrong Unicode character. No, the user's console, this is it. The user's console doesn't support Unicode characters. That's why it's not being shown out there, right? So we'll check our answers. We're good. Continue without saving the progress. See that that last answer was correct. And that is everything I wanted to get through within the workshop. A couple of last things I want to say in the wrap up, and then I'll take questions. Come on, why is my... Here we go. Let me get into full screen for a moment. I'll come into the back. So what I did, basically, so you know this, I wanted these slides to kind of be a summary of what we talked about. So here it is. We talked about storing and retrieving data, literal values and variables. We talked about both of those. We talked about these sets of types, string, character, integer, Boolean. We covered all of those, right, along with decimal as well. I showed you about variables, declaring a variable, assigning to a variable, retrieving a value, reassigning, and also implicit typing. We talked about basic string formatting with escape characters, verbatim string, string concatenation, string interpolation. I showed you an example here of escape characters, and here it is on the slides. Kind of, I'm intending these slides to be an accompaniment to what you have in the instructions. And then the Unicode escape character \u, I mentioned that. Here's verbatim strings and string concatenation. Here's string concatenation here. Here's a verbatim string with an @ sign in front. And here's string interpolation, right? And I want to do a quick summary and conclusion. So the items we covered in this workshop are C# basic syntax, storing and retrieving data in applications, and basic data formatting. You should remember, here's the conclusion, C# is the most powerful programming language for .NET that provides productivity and versatility and it's a great starting point for becoming a .NET developer. Here are some additional references. The C# guide. This is a great place if you're looking for a general guide on C#. The documentation is here. Also, I put in a link to the set of things we went through is all part of a larger set of workshop instructions for taking your first steps with C#. And we covered the first three. We covered write your first code in C#, performing basic string formatting and basic operations. But there's a lot more. In fact, here's the full set right here. If you go to this link that I put in on the very last slide, that will take you to all 8 of the pieces of the workshop. And we just did 3 of those, right? We did the first 3, but you might want to go in and do the other 5 as well if you want to do the full set for taking your first steps with C#. And then finally, please do the Reactor Survey. I put in a link. It's there in the slides. I always like to have people do the survey. You know, let us know what you thought of it and what could be improved. But that's the last piece. I will now take questions. Anything anyone have?
Thanks, Ron. We did have one question come through at the end there, but I believe you answered that in what's covered in the learning modules. So thank you so much again. We'll give everyone another minute or 2 to ask a question. We've got a couple of minutes left. And as you mentioned, all of those links that you've shared today are available via that Dropbox link that Ron has kindly created, and I'm just popping that one up on the screen again now. So any links, any learning modules, or any of the web pages that we use today for the demo and presentation are available via that Dropbox link. And also mentioned is the survey, and the event code for that one is 15874. So if you have time to fill that out today, that would be awesome. I've just put that up on the screen now.
Oh, you put it up on the screen. Okay, I don't have to then. Okay.
Great. Thank you so much, Ron. I think that is all we have for questions. Thank you, everyone, for engaging in the chat. Yeah, all of those links are in the Dropbox that someone just asked. So thank you very much again for being part of our Build Skills series and today's C# lesson. So thank you very much again, Ron. Thank you, everyone. Sure. Have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor live stream event.
I'll hang around a little bit, Sarah, if you want to talk about anything. So,
sure, sounds good. Thanks, everyone.